Hey all, welcome back to my channel. Today I have brought a video on overview of area problem, which is a topic from FYBSC CS Sem to calculus. So let's get started. Now what is the area problem? If I ask you what is the area of rectangle, so you will say कि अच्छा मैम length into breadth है. Area of triangle, that depends on what kind of triangle it is. And if I ask you the area of circle, of course you will be able to say that it is pi r square. But I would ask you a question, what about the area formula for the regions which are going to have some curved boundaries? So for that, the first real progress regarding the area formula for such curved surfaces was made by the Greek mathematician Archimedes. So he did a method of exhaustion. Now what is this method of exhaustion is? We would be trying to inscribe a regular polygon into that curved surface, and we'll be exhausting that curved surface by increasing the number of sides of that polygon. Like for an example, it is a circle, and if I try to just inscribe a triangle in it, of course the area of circle we know that it is pi r square, and triangle if we are taking, we are not going to get the area of this remaining part, this white regions, correct? But if I replace the triangle by a square, means I increase the number of sides of my polygon, then I would get a bit better area than whatever I got by inscribing a triangle. यही मैं अगर pentagon inscribe करूँ तो I will be able to get more closer to my area, to my required area, correct? Hexagon तो और ज़्यादा better. तो method of exhaustion ये था कि हम polygons इंस्क्राइब करें और वहाँ पे जो भी पॉलीगॉन इंस्क्राइब करें हम उसकी नंबर ऑफ साइड्स बढ़ाते जाएं. तो जैसे जैसे हम नंबर ऑफ साइड्स बढ़ाते जाएंगे विल बी रीचिंग मोर अप्रॉक्सीमेट टू ओवर एरिया. सो जैसे यहाँ पे ट्राइंगल से स्टार्ट किया था एंड स्लोली इफ आई एम जस्ट गोइंग टू इंक्रीज ऑन द साइड्स एंड ऑल ऑफ माई पॉलीगॉन, यू सी मच मोर अप्रॉक्सीमेट एरिया आई विल बी गेटिंग. अब ये फिगर देखोगे तो इट इज़ मच क्लोजर टू व्हाट सर्कल लुक्स लाइक, करेक्ट? सो ये वाला जो फिगर होगा जहाँ पे n साइड्स बहुत ज़्यादा है, वहाँ पे मुझे मोर अप्रॉक्सीमेट एरिया ऑफ माई सर्कल मिलेगा. तो ये था मेथड ऑफ एग्जॉशन. सो द एरिया प्रॉब्लम कैन बी स्टेटेड एज गिवन अ फंक्शन f that is continuous and non-negative on an interval a comma b, you have to find the area between the graph of f and the interval ab on the x-axis. So this can be shown by this particular diagram where r is my region. So this r is a area under the curve. My curve is f of x, that's continuous and non-negative. तो इसके नीचे का कर्व और किसके बीच का कौन से इंटरवल्स के बीच में? इंटरवल a and b के बीच में. So given a function f and a interval, we have to find the area between that function f and between that interval ab on the x-axis. Now what was rectangle method of finding the areas? As you see these three diagrams, I am having the curve y equal f of x and I am having a interval ab, correct? अब यहाँ पे अगर ab इंटरवल को मैं सब इंटरवल्स में डिवाइड करूँ, n सब इंटरवल्स में डिवाइड करूँ और एक रेक्टेंगल ऐसे ड्रॉ करूँ, तो फिर हम रेक्टेंगल का एरिया तो फाइंड कर सकते हैं क्योंकि हमको लेंथ एंड ब्रेड्थ पता रहेगा. सो जो भी एरिया होगा कर्व का वो ये सारे रेक्टेंगल के एरिया को सम अप करके थोड़ा बहुत अप्रॉक्सीमेट उसके पास में पहुँचेगा, करेक्ट? सो इफ़ आई से दिस इज़ माई कर्व, yes, and this is my interval, so I am going to just make sub intervals. So this is my n equal sub intervals, and over that sub interval I am just going to draw the rectangle. You see, I am able to draw the rectangle like this way, and I will try to find the area of these rectangles and then I can sum up. So that would be giving me approximate answer for my area under the curve. तो जितना आप सब इंटरवल्स ले रहे हो उस पर डिपेंड करेगा. जैसे यहाँ पे हमने कम सब इंटरवल्स लिए ना, 1 2 3 4 5 सब इंटरवल्स आ दे, सो थोड़ा ओके अप्रॉक्सीमेशन आएगा. बट यहाँ पे द नंबर ऑफ रेक्टेंगल्स हैज़ बीन इंक्रीज, तो ज़्यादा अप्रॉक्सीमेट आएगा एरिया का आंसर. और यहाँ पे देखो, यहाँ पे तो कितने सारे सब इंटरवल्स लिए हैं, तो देखकर हमको पता चल रहा है कि इट विल बी मोर वेरी मच अप्रॉक्सीमेट टू द एरिया अंडर द कर्व ऑफ दैट पर्टिकुलर फंक्शन. इफ़ वी जस्ट एड अप the area of all these rectangles will be getting more approximate value for the area under this curve. That was the rectangle method of finding the area. Now what is antiderivative method for finding the areas? Though the rectangle method was much appealing, still Leibniz and Newton wanted some progress in this area problem, so they came up with this antiderivative method of finding the area. So what this method says, if f is a non-negative function and it is going to be continuous over the interval ab, and if I consider a of x, which denotes the area under the curve for that particular function, okay, over the interval ax, where x is any point in the interval a comma b, then a dash of x equal f of x. So this was the antiderivative method which says कि अगर आपका f नॉन नेगेटिव और कंटिन्यूस फंक्शन है और आप इंटरवल a कॉमा b कंसिडर कर रहे हो और a of x आप एरिया कंसिडर कर रहे हो ओवर द इंटरवल a कॉमा x and x is a point in the interval a comma b, then we can say that a dash of x is equal to f of x. We'll solve a question how that a dash of x is equal to f of x, correct? So for each of the function f, we have to find the area a of x between the graph of f and the interval a comma x, which is given as -1 comma x, and we have to find the derivative a dash of x for that area function. These are the three functions I will show you for this and this. See, आपको interval दिया है ax, that is -1 comma x, and you have to find the area a of x, and we have to also find the derivative a dash of x for that function. Now if I say f of x equal to, if I want to draw the graph of f of x equal to, तो हमारा ग्राफ कैसे दिखेगा? y equal 2 पे पास होगा लाइन, करेक्ट? y equal 2 पे क्या हो जाएगा? लाइन would be passing from y equal to 2. Now they have given me the interval क्या? -1 comma x. So where is -1? -1 is somewhere here and x is here. Just I consider this as my x. X is here. I draw vertical lines over here. So this is a rectangle shape that I am getting. Okay, so the breadth is 2. This is my breadth. This has become my breadth, and this is my length, right? This is my length. From 0 to x, this is x, और यहाँ का ये +1 यूनिट, राइट? सो x + 1 इसका लेंथ हो गया, समझा? ये जो वर्टिकल है वो तो 2 हाइट पे, राइट? सो दैट बिकम्स अ ब्रेड. ये x + 1 लेंथ कैसे हुआ? क्योंकि 0 to x तो x वैल्यू रहेगा और यहाँ का एक 1 यूनिट ले लिया, सो दैट इज x + 1. So my length and breadth I have got. Now this is a rectangle shape that has came, so I know that area of rectangle is what? Length into breadth. My length is 2 and the breadth is, okay, so the length is x + 1 and the breadth is 2, so I just get this 2x + 2, correct? So area that we are getting, a of x, is 2x + 2. If we try to find the derivative of this, let's find the derivative. Do d by dx of 2x + 2. What we will be getting? We will be getting 2, correct? 2 will be the a dash of x, the derivative, and this 2 is equal to what? Our f of x. So that is what is the antiderivative method, that if you are having a function f of x and you are given an interval, here our interval is -1 comma x, you are given an interval, and if you are considering a x point between that interval and a of x is your area, then the derivative will be equal to the f of x. Let's consider the another question, which is f of x equal x + 1. So when I try to draw this function, it will be like this way, right? x + 1 का जो आप ग्राफ प्लॉट करोगे वो ऐसे होगा, y equal x + 1. So when we see the base part, it is 0 to x और यहाँ पे 1 यूनिट. So 0 to x यानी कि x वैल्यू, यहाँ पे 1 यूनिट, so it is x + 1. When I'm taking the height, I'm just considering this as my x. When I'm taking the height, it is also x + 1. Okay, so this is a triangle shape that is formed. Area of triangle is what? Half into base into height. So I just consider half. Base is x plus 1 and the height is x plus 1. So when we just solve this, we get half x plus 1 the whole square. So that is half x square plus 2x plus 1. So we are getting half x square. Just if it multiply half through inside, we'll be getting x plus this would be half x. So I'll be finding the derivative. Half will be treated as constant. Derivative of x square is 2x. Derivative of x is 1 and derivative of constant is 0. So what I get is x plus 1 and that is equal to by f of x. So we have found the area between the graph of f and that interval, as well as we had also found a dash of x for the area function. So the process of finding a function from its derivative, it's called antidifferentiation, and the process of finding areas via antidifferentiation is called as antiderivative method. When we are finding a function from its derivative, we are antidifferentiating, and the way we try to find our areas by antidifferentiating is called as antiderivative method. So I hope you would have liked the video. If you have liked the video, please click on the like button. Do share it to your friends and subscribe my channel. Stay tuned for more such videos. Thank you. Till then, take care. Bye.